How to analyze a core dump with GDB for troubleshooting. Have you ever faced a situation where your program crashes unexpectedly? It can be frustrating, but fear not. Analyzing a core dump can help you figure out what went wrong. A core dump is essentially a snapshot of your program's memory and state at the time it crashed. Using the GNU Debugger, also known as GDB, you can dive into this snapshot and identify the cause of the crash. Let's walk through the steps to analyze a core dump with GDB. First, before you can analyze core dumps, you need to ensure your system is set up to generate them. You can check the current core dump size limit by running the command ulimitc. If it shows 0, core dumps are disabled. To enable them temporarily, use ulimitc unlimited. For a permanent solution, you will need to modify system configuration files like etc security limits conf and /etc /sysctl conf to set the core dump size and location. Next, when a program crashes, the system creates a core dump file. This file is often named core or follows a pattern that includes the program name and process identification number. This file contains the memory image and process state at the time of the crash. To get meaningful information from the core dump, compile your program with debug symbols enabled. You can do this by adding the G flag during compilation. This allows GDB to map memory addresses back to your source code lines and variable names, making it easier to understand what happened. Now it's time to start GDB. You can do this by specifying the executable and the core dump file with the command GDB to executable to core. This command loads the program state at the time of the crash for inspection. Once inside GDB, you can use the bt command to see the backtrace. This shows the sequence of function calls that led to the crash. You can also examine local variables and function arguments at each stack frame to gather more information about the state of your program. To inspect variable values, you can use the command print variable name. Additionally, you can examine memory directly with the x command. This is useful for identifying issues like invalid pointers or corrupted data that may have caused the crash. Another helpful command is info registers, which displays the contents of the CPU registers at the moment of the crash. This can help diagnose problems related to invalid memory addresses or illegal instructions. If your program uses protected memory regions, or if the core dump excludes some memory due to security settings, you can configure GDB to ignore these filters. Use commands like set useCoreDumpFilter off and set dump excluded mappings on to get a more complete dump for analysis. Debugging with core dumps is often an iterative process. You will want to explore different stack frames, variables, and memory areas to piece together the cause of the crash. Use GDB commands such as frame, up, and down to navigate the call stack, and list to view the source code near the crash point. A few practical tips can make your debugging process smoother. Always compile your program with debug symbols for effective core dump analysis. Set core dump file locations to a dedicated directory for easier management. Core dumps are especially useful for debugging intermittent crashes that are hard to reproduce in real time. You can also combine GDB analysis with other tools like Valgrind for memory error detection if needed. By following these steps, you can effectively use GDB to analyze core dumps, identify programming bugs, and troubleshoot crashes, ultimately improving the reliability of your software.